whereas constant value will never change during the execution of the program, but when we come on variable, its value will change at the time of execution. The fundamental data type is also called as simple data type, or we used to call it as built-in data type also. The simple data types includes int, char, float, double and void. These are the fundamental data types which we are using. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with first session of data types chapter. Whereas in the annual exam, from this chapter, you will get only one question, that is on part B, only for 2 marks. The total weightage of this chapter is only 2 marks in the annual exam. Only simple question you will get from this chapter. Whereas on this session, you will come to know regarding introduction to data types. What do you mean by data types? Why we require these data types? Then under that, what do you mean by variables? Whereas when they come on constant and variables, whereas constant means its value will never change during the execution of the program. But when they come on variable, its value will change during the execution of the program. Then how to initialize a variable? How to initialize, how to assign a value for a variable. Then data types classification. How exactly the data types are classified, like simple data types, derived data types, like that, the classification of data types. Then under that, you will come to know regarding simple data type or fundamental data type. Now one by one we'll discuss. First we'll start with variables. Already I told you, when they come on constant, its value will never change during the execution of the program. But when they come on variable, its value will change during the execution of the program. Whereas variable is an object, or we can say it is an element, and it is allotted change during the execution of the program, and mainly it is allowed to change the execution of the program. Whereas constant value will never change during the execution of the program, but when we come on variable, its value will change at the time of execution. A variable represents the name of the memory location. Where exactly in the memory that element is present, it represents the memory location. And if I want to declare a variable, then the general syntax we have to follow data type, then variable name. While giving name for a variable, some rules and regulations we have to follow. Here it should be single word. In between we are not supposed to use any space. If you want, you can use underscore here. Except underscore, you are not supposed to use any other characters, other special symbols especially. If you want, you can use characters, digit or underscore. And with that, the first character must and should be alphabet or underscore, but it's not supposed to be start with the digit. While writing the syntax, data type, variable name we have to write. Then a variable name is an identifier. Usually it is an identifier. These variables are used to denote the constant, arrays, functions, structure, classes and files. For example, if I'm going to write int a, then a is a variable of type integer. It means that a will store the value of type integer format. For example, if I'm going to write float b, then b is a variable of type float. It means that first we have to mention the data type, then later on we have to mention the variable name, then at the end you have to put semicolon. Now we will explain regarding how to initializing a variable, how to assign a value for a variable. There the syntax is data type, then array name equals value. Here we have to write. For example, in this case, int b equals 100. It means that we are assigning the value 100 for the variable b. For example, if I am going to write float x equals 10.06, then it means that this value is assigned for the x variable. It means that here data type, then variable name equals whichever value you want to give for that variable. That value here you have to write. That is nothing but initialization, assigning the value for a variable. Next, we'll discuss about the data types classification. How we are classifying the data. Data types can be defined as the set of values. Already I told you which type of value here we are storing. Values which can be stored in a variable along with the operation that can be performed on those values. Usually on those variables we are performing the operation and that variables will store the value. When they come on C++ data types can be classified as the fundamental data types. The fundamental data type is also called as simple data type, or we used to call it as built-in data type also. The second one here, derived data type, and the third one is user-defined data type. First one simple fundamental, then derived, then finally user-defined data type. Now one by one we'll discuss. The first one, simple data type, or we can call it as fundamental data type. Fundamental, generally which are the data types here we are using? Like we are using integer, character, float, double, as well as void are the fundamental data types. The simple data types includes int, char, float, double and void. These are the fundamental data types which we are using. Whereas int means it stores only the integer value. For example, if I am going to write 16, then it is an integer value. After 16, if you have any values where it may be 0 or anything, for example 0 or 01, anything, then it can be called as float value. Integer does not contain any fractional part, whereas float contains the fractional part. But when you come on character, there it contains only one characters. For example, A, B, any character you can take, and it is opened as well as closed by single quotes. And then double. With that, we have void also. These are the major fundamental data types. Now, one by one we'll discuss. Under simple data type, the first one, int type. Whereas already in the beginning class itself, I told you C++ is a case-sensitive program. It means that in uppercase, if I write int, as well as in smaller case, if I'm going to write int, then it will give specific meaning. It means that in uppercase, it is going to give some specific meaning. In smaller case also, it will going to give some specific meaning. Whereas int type, already I told you, int means it contains only the integer part. It does not contain any fractional part at all. An integer are whole numbers without any fractional part. We does not have any fractional part, not even 0 also. This includes the numbers such as, for example, 1, 45, minus 9. These are some of the integer value. For example, if I am going to write 4, then integer. 4 point, if I am going to write any value, if it is 0 also, then it cannot be called as integer. If I have any fractional part, then it can be called as float value. When they come on 5.2, for example, then it is not an integer because it contains a decimal point. After a point, we have some value. Then it cannot be called as integer value. An integer can be positive or negative value. If I want, I can take positive value. For example, minus 4 or plus 4. All are integer values where it may be positive value or it may be negative value. And the range of numbers we can store from minus 32782 plus 32767. Till that range we can able to store these integer values. When we come on the next one, character data type. While pronouncing character data type we use, right? While writing CHAR only you have to write. Whereas in the previous case, for integer, while pronouncing integer data type we used to say, but while writing int only you have to write. For character, CHAR, character type here. It is a character data type to store only characters from the basic character set. From the basic character sets, whereas it may be in uppercase or it may be in lowercase. If it is uppercase, then it is in capital letter. Lowercase means it is in smaller case, that is in small letter. Characters are enclosed in a single quotation mark. For example, here if you observe A we are written inside the single quote. If I'm going to write small a, that also written inside the single quotes. B, plus, minus, everything we have to write in single quotes. If I'm going to write n, then it's a character. It is open as well as closed by single quotes. When a variable of type character is declared, the compiler converts the character to its equivalent ASCII code. Whatever character we will write, that character automatically the compiler will convert that into ASCII code format. ASCII code means American Standard Code for Information Interchange. On that format, automatically it will convert. When you come on this character data type, here a character is allowed only 1 byte of memory space. When I declared char A, that's the character data type because A will store the data of type character format. For that, we require only 1 byte of memory space, whereas 1 byte is nothing but 8 bits. 8 bits equals 1 byte. Here, it takes only 1 byte of memory space when I'm declared as character data type. The character is represented in a program by the keyword char. Compulsory, we have to use the keyword char, C-H-A-R only you have to write. The general form of character declaration is, first you have to write char, then variable name or variable list, here we have to write. For example, here char alpha equals A. Here we are initializing the value A for the variable alpha. If I want, I can write char M. It means that M is a variable of type character format. Now is it clear? Next, we'll move on to float type. Whereas already you come to know the difference between integer as well as float. In integer, we does not have any fractional part, whereas in float, we have fractional part. This represents the number with a fractional part, that is a real numbers. It contains the fractional part, where the fractional part may be 0 or any number. The float is used to store the real number, especially to store real numbers, we are using float concept. The numbers such as, for example, 1.8 here we are given. It means that after point we have some value. That is a float data type. Here 4.5, that is also float data type because after point we have some values. 12 e to the power of minus 5, that is also of type float format. That means here we have the fractional part. It can also be both positive as well as negative number. In integer also it may be positive or it may be negative number. The range of number we can store minus 34 e to the power of minus 38 to 3.4 into e to the power of plus 38. But here if you observe in this float contains, especially it requires 4 bytes of memory space, whereas integers requires only 2 bytes, whereas float requires 4 bytes of memory space. Float is allocated 4 bytes of memory space. 4 space is nothing but 32 bits of space it requires. The general form of float declaration is float, then variable name, here you have to write. For example, here float of A equals 5.5 we are given. It means that 5.5 is assigned to the variable A here. For example, if I am going to write float B, here B is a variable of type float. It means that here it stores the value of type float format. Then if I am going to write 100, that means 100 will assign to this B variable. Now is it clear? Next, when you come on the next type is double type. Now you come to know integer type as well as character type, with that float type also. The next one is double type. When you come on double type, the double and float are very similar. The float type allows you to store single precision floating point, whereas here float allows you to store single precision point, while the double keyword, especially here when they come on While double keyword, there if I'm going to use the double, then it allows you to store double precision floating point numbers. If I'm going to write float, then here it will take single precision. If I'm going to write double, then it will take double precision point here. And its size is typically 8 bytes of memory space it requires. If it is integer, 2 bytes. If it is float, 4 bytes. If it is double, then 8 bytes of memory space it requires to represent. The range of number we can store for this one is minus 1.7 into e to the power of 308 to 1.7 into e to the power of 308. Till that, the range will comes here. And here, the general form to declare that double variable list here you have to write. It means that first here we have to use the keyword double. On the place of int, character, float, mention it as double, then variable name, then equals. This value is assigned to the variable A with double format here. Now is it clear? It means that now you come to know int, character as well as float with that double. And the next one we have void type. When they come on simple type, I told you 5 types. One is int, character, float, double, and one more is void. The name itself suggesting void, it means that we are not going to get any written type of values here. Void, the name itself suggesting void, we are voiding the values, especially here. The void type have no value and no operations here. In other words, both the set of values and set of operations are empty here. For example, void main if I'm going to consider. Then in this void main, in this declaration, the main function does not return any value. For example, if I'm going to write void main, then consider this is a main program and this is a subprogram. If I'm going to write void, it means that no values are passing from subprogram to main program. If I'm going to write void. In the same way, no values are passing from main program to subprogram, then also we can use void concept. Void helps to, there is no transfer of any values here. Then here if I come to the data types as well as how much bytes, how much memory space it requires, and with that range and example here we are given. For example, int, already I told you, it requires 2 bytes of memory space. If it is character data type, then it will take only 1 byte of memory space. If I consider as a float type, then it takes 4 bytes of memory space. If I want to consider double, then it takes 8 bytes of memory space, because here single precision it will take, whereas here it will take double precision, and this is a range of that data type. And here we are given example here 800 minus 39, because already I told you it may be positive number or it may be negative number. That's why 8 is an integer value, 100 is also an integer value, minus 39 is also an integer value. And if I'm going to take character, there everything we have to write in the single quotes. Only one character it contains, and it is opened as well as closed by single quotes here. Opened as well as closed by single quotes. But when they come on float, there it contains the fractional part. Here if you observe 45.345. After point we have some values. That is float. For example, 0.134. After point, if you have some values, then it can be called as float data type. And the next one, double. Here, after point, if you have large number of fractional part, then we can call it as double. Now, once again, I am to recall everything. Here, whereas variable, its value will never change during the execution. Then, how to initialize? Variable name equals, whichever value you want, you can assign. Then, when they come on classification, fundamental or simple data type, derived data type, and one more is user-defined data type. And the next one, when they come on simple, we have int, char, float, double, and void. But when they come on, especially the data type, under that, we have simple, derived, as well as the next one here, user-defined data type. But when they come on variable, especially there we are going to get L value as well as R value. L value as well as R value. Whereas L value will store the location, where exactly in the memory, on which location that element is present. whereas R value contains the actual information. What is the actual information? What is the actual value it is contains? Whereas L value, location value, on which memory location that element is present, whereas R value represent which is the exact value on that location it contains. Next, simple, here under simple int, char, float, double and void. When we come on integer, we does not have any fractional part where it may be positive or negative, while it takes only 2 bytes of memory space. And the next one, char, under char it takes only one character. It is opened as well as by closed by single quotes, but it takes only 1 memory bytes of space. And the next one, float, whereas in float, it takes the fractional part, but it contains 4 memory space. It requires 4 memory space. And here, the general syntax here, float, variable name, and here if I want, we can able to assign the value. And the next one, the double, whereas in double, it requires 8 memory space. Whereas when we come on the next one, void, there it does not return any value. Now is it clear? Next class, we will explain the remaining concept of the same chapter. Thank you for all of you.